Welcome back, folks. Today we're going to take a little break from the Yamaha YL1 project. I do have a lot of videos I've been shooting over the last few weeks that are queued up to be released, and I've been hitting it pretty heavy here in the last month or so. So you'll have those coming up. In the meantime, I thought I would do a little shop talk video. This would be number 7, and I thought I would talk about zinc plating. And I think if you've been watching my channel at all, you probably have heard me reference zinc plating from time to time. And in fact, I have some videos I've already shot that include some zinc plated parts that we'll be talking about in more detail on these videos. Today what we're going to do is we're going to actually zinc plate, and I'm going to try to keep this video as short as I can. I don't know how many parts it's going to be. It might end up being a multi-part video before it's over. I have a fair amount of material I want to cover. Now, it's entirely possible there are already videos out there regarding zinc plating. There probably are. I simply haven't gone out and looked for them. And my intent is not to duplicate content, but rather to share with you the process that I have evolved into over the years with zinc plating. I've been doing it for quite a long time now, and like most endeavors, when you first start it, you're learning. And now that I've been doing it for a while, I have settled in on a process that works for me, which may or may not align with other people's. It's really irrelevant for me because this is what works for me, and I thought I would just share it with you so you know the process that I have used and developed over the years. For today's video work, we're going to actually zinc plate. These are a couple of parts off the Yamaha. These are the small little clamps that go over the air intake boot that comes down from the air cleaner canister and goes around the mouth of the carburetors. And there's 2 of them, of course. And I'm actually going to demonstrate plating of one of these. And we're going to talk through the key elements that one has to pay attention to, the major steps, some of the tools and equipment that one can use, at least that I use. And I'll finish with taking a good look at the finished plated part, so you can see how it comes out versus one that is not plated. Obviously, eventually I'll have to plate both of these, but I'm going to do only one to demonstrate for the video today. That's really the content that we're going to go through. I think first what we're going to talk about next is the setup and the equipment and the bath that you soak or use for the plating process. In other words, tools and materials, and that's going to be the next part of this conversation. We're going to start with talking through the basic tools and materials that I use for zinc plating. I have a power supply that's here. That's a variable speed power supply. I bought that on eBay about 6 or 8 years ago. That's a real handy tool to have, and I'll come back to power supplies in a bit more detail in a moment. You'll need a source of zinc to transfer to your part. This is a roll of zinc. It's a very large roll of zinc. You can see, I think, here. This is nothing more than a roll of material that's used at the roof line of homes, and it's typically attached when you have asphalt shingles along the roof line, and is used in a sacrificial fashion so that as it rains, if you're in a damp climate, for instance, or have a problem with mold or mildew on your roofing, this is attached to the roof line. As it rains, it self-sacrifices, runs down on the shingles, and actually keeps mold and mildew away. Mold and mildew, zinc kills mold and mildew. And you can buy commercially available zinc from places like Eastwood that's already cut into strips, a little bit thicker than this, but it's zinc. You can buy bars on eBay and other sources, sacrificial anodes for lower units of outboard motors and that kind of thing. I bought this at a local big box store, Menards, quite a long time ago, and it'll last probably my lifetime plus, probably my grandchildren's lifetime too. And it's relatively inexpensive, it's thin, it's easy to cut with scissors, And that's my source of zinc. Again, there are other ones out there. And then a solution or bath, and that's what we have here. And this is a homemade solution. This is not acid. Many of the solutions, especially commercially made solutions, again, you can buy from eBay, Eastwood, and other sources, are a form of acid. I don't use acid. I started out using acid years ago. I have this homemade solution, and I'll give you the recipe to that in a few minutes. That works just fine. I've used everything you see here, the power supply, the zinc in a roll, and this solution for a long time successfully. And in fact, these anodes right here, you can see I've cut into strips, have already been used for another project. In fact, I think these were used on the air cleaner canister for the Yamaha project that I've been working on. And you can see where it's been immersed in the solution. This is the basic kit that I use. Again, you can use acid, but I don't. You can come up with other sources of zinc, but I found this is inexpensive and works quite well. Let's move on to talking about power supplies. I use a variable speed, or variable current, I should say, not speed, power supply, and you have both voltage and current or amperage. What you really are concerned about in zinc plating isn't voltage. So this side I virtually don't use these two controls at all, but I do use the current or the amperage because that's what you are trying to regulate as you zinc plate. Now you don't have to go out and buy a variable speed or variable current power supply like this. You can use batteries. And you will see probably if you do research out there, people that use batteries, 6-volt, 12-volt batteries. You can use both the small alkalines. You can use even car batteries, I suppose, though I have never used car batteries. You can also use, and I'll reach across here, something like this, which is actually what I used for a while. And this is nothing but a variable output transformer from a model railroad. Some of you might know that I have been into model railroading most of my life. I haven't done much of it recently, but this is a variable speed power supply. That's all it is. And this is quite old, but it works fine. It does work for plating. I used it for quite some time for plating. It doesn't provide quite the level of control that this unit does, but it does work, and you can find these quite inexpensively used, and even I think they're probably still making them new. The most control systems for model railroading have moved on beyond this kind of technology, like most things in life, but it does work. So there's three sources for a power supply. One is batteries, both alkaline or car batteries or some other form of a battery, a variable speed power unit like that model railroad transformer I just talked about, and there's other probably versions of that for other processes and other equipment, or a true variable power supply like this one that is really designed, I think, for laboratory and scientific work, and this has worked really well. You'll notice that, just to remind myself, I did put a little cheat nomenclature here. The red wire here goes to the anode, and the black, which is this, the sacrificial piece of zinc, that's the anode. And then the black goes to the part being plated. Because sometimes it'll be months between projects for me, and I might just forget which goes where, and I'll have to look it up. So I just put that little cheat sheet on there. Let's talk a little bit more about the solution that I use. And I'm going to go over the computer here, and I'm going to show you the formula, the actual formula that this is comprised of. Now this is reusable. Well, it's a little less than a gallon, I suppose now. It was a gallon when I started, but has been used many, many times. This is probably literally 6 or 8 years old. I do filter it through a coffee filter from time to time to get out any impurities or solids that might settle out as this breaks down. But I keep using it over and over and over. And if I need to make a bigger bath, I have the chemicals, and there's not a lot involved actually. I do have all the chemical or the materials available in my shop to make more if I need to, but that's pretty rare. I don't think I've had to do that in some time. So let's go over to the computer, and we're going to talk about the formula that I use for the plating bath. There's the basic formula that I've been using for zinc plating for the solution bath for years. And most of those items are readily available. Probably the most challenging one for most of us would be the zinc sulfate. The rest of it is generally household items or very, very close to it. In terms of Epsom salt, I bought this years ago at a local, I think I bought it at a local pharmacy just down the road from me in the little burg where I live. This one came in a carton. The zinc sulfate, very readily available. You can buy that on eBay. You might be able to order it through a pharmacy. I don't know. I bought this on eBay, and it was inexpensive. It's a powder. Then, of course, white vinegar, household item, sugar. This is plain white table sugar, and clean tap water. You use the proportions you see there. If you're not comfortable working in the metric system, you can convert those figures, the 128 grams, 43 grams, etc., to imperial measurements. You're all very smart guys out there. I'm sure that won't be a challenge for you if you wish to convert that to imperial. I just use the metric measurements. It's easy for me as imperial. Actually, it's easier for me than imperial. You measure those out carefully, within reason. When I say carefully, you don't have to be to the nth degree, but be reasonable about your accuracy, and just mix it up well. Mix it up with a clean stirring stick until it's the zinc sulfate and the sugar, in particular, and the Epsom salt, are completely dissolved, and you'll see that happen. And then you'll have your solution. I believe, if memory serves, the recipe you see here makes up a couple of liters of bath. I believe it makes up around 2 liters. I'd have to do a little quick mental gymnastics, but I believe that's about a 2 liter, or for those of you in North America that don't work in metrics, 2 quarts approximately, or half a gallon of solution. And you can scale it appropriately as you think you might need to. Either way, make more or less. Again, I save mine, and generally don't often have to mix up anymore. It's been years since I've mixed up any solution. But that's a basic recipe for the bath. We've talked about the formula for the plating bath. We've talked a little bit about power supplies. And again, one other thought that occurred to me a moment ago is you can use things like wall warts, those little plug-in power adapters for various electronic components and chargers and that kind of thing. The only thing you have to pay attention to is you don't want to have too much current output from those. That'll create a problem when you go into your actual plating, which I'll talk about here a bit later as I get into the plating of that part. So I've talked about this, and this. Let's now talk about item preparation, item being the part you're actually going to plate. Now this is one of those 2. There's the second one. And you can see the finish appears to be different. And it is, for a simple reason. And this one has been essentially polished. Now this is raw steel. There might be some zinc, original zinc left on here, I'm not sure. But this is essentially raw. This just came out of the blast cabinet, the media blast with glass beads. And you can see it's quite a bit duller. There's 2 key elements you have to keep in mind when you're preparing parts for plating. One is it has to be clean, and I mean virtually antiseptically clean. And by that I mean just like you prepare anything for painting, preparation is the key. So all oil, paint, previous oil, paint, any kind of contamination, including fingerprints, cannot be on the surface, or it will interrupt the flow of the current and the zinc, and you will be disappointed with the results. So this has to be very thoroughly cleaned. I typically use clean acetone and or brake cleaner, and clean, usually fabric rags, shop towels that are perfectly clean to prepare these the item for plating. So cleanliness is important. Second major point of conversation is there can be no rust. Now, I mean none. Zinc will not attach itself to rust or iron oxide. It has to be thoroughly derusted. And that is the reason why I go through the multi-step process that I do, where I will typically bead blast it while clean it, wash off all the grease and oil, remove any obvious loose paint. Then I will bead blast, typically, soak it in a rust remover product that you've heard me reference several times, usually at least 8 hours, if not overnight or 24 hours. Then I go back to the bead blast cabinet, blast it again, goes back into the rust removing solution for 8 to 24 hours, and then back to the bead blast cabinet for the last time, and it comes out looking like this. And I alternate those cycles because bead blasting doesn't always get into the nooks and crannies and crevices and creases here, like you can see, of some parts. And I alternate back and forth to make sure that I thoroughly have removed all the rust in any previous finish, of course. Once it comes out of the cabinet, it'll look like this. Then what I'm going to do is want it to look like this. Now, the reason being, and you could plate this, that would work. You could clean it good thoroughly in acetone or with fresh brake cleaner, and you could plate that. The reason I bring up the brightness of the finish is the brighter the stock is starting, such as this, the brighter the finished zinc will be. The duller the starting finish, such as this, the duller the finished zinc will be. It'll still be zinc plated, it just won't have quite as much pop, if that's what you're after, as brightening up the finish. So in order to go from this to this, I simply take this over to the wire wheel on my pedestal grinder, that little Black & Decker unit I reconditioned a while back that was on the channel, and I just cleaned all this up on the wire wheel to brighten it up a little bit. Now, in terms of getting into the crevices here, I just grabbed this little wire. It's quite a fine wire brush, because obviously you can't get into all of these crevices with the bench grinder wheel. I just use a brush like this and do this kind of thing as best I can to clean in where I can't maybe get the inside, for instance. I'll spend a little time doing this kind of thing just to brighten up the finish as best I can. And in some cases you're not going to be able to get in all the crevices to brighten the finish. That's okay. In this case it was pretty easy to do this outer band around the captured nut here and to brighten it up. So the point of that conversation is cleanliness, number one, that is contamination. Number two, you can have absolutely no rust of any kind, or your process isn't going to work where there's rust. And then three, which is really optional if you want to brighten up the finish a little bit, spend some time with a wire brush, spend some time with a bench grinder safely, and trying to brighten up the finished part. What we're going to talk about next is setting up the bath, setting up the part in the bath, suspending it, and how to go about preparing the setup for the actual plating process. Here's our subject part, a little clamp. It's been thoroughly cleaned first in acetone, clean acetone, and then I, for good measure, hit it with a strong spray and clean scrub brush with brake cleaner. and I have allowed it to dry, so it's as clean as I can get it. Now you'll note I'm wearing clean gloves, and the operative word here is clean. What you don't want to do is use gloves, reuse gloves that have grease or oil or paint or something on these. I just pulled these right out of the box, and so I know they're clean, because I don't want to contaminate this with hand oil. So the part is prepared and ready to go. You'll notice I've got a clean container here. This happens to be plastic. You can use glass or plastic. I would not recommend using metal for obvious reasons. You might end up, depending on how you configure your setup, you could end up plating the container. I've used both glass and plastic. Both work fine for this demonstration, for this purpose, rather. I got a cross beam. This happens to be a piece of copper wire. It doesn't have to be. I just use a lot of copper for something like this. As well as I've got a piece of stranded copper wire, I think you can see right there. There's actually going to be the item that's going to connect, or suspend rather, the clamp and the plating solution. So what I'm going to do, and I'm just going to do it for you right here and show you how I'm going to go about this. I'm going to thread that through. This is fresh and clean copper wire. I have used it before for plating, but I know it's clean. And as this is a very lightweight part, I don't have to be concerned about weight at this point. As you do more and more plating, zinc plating, you'll discover you have to be somewhat creative to MacGyver solutions to suspending parts in the solution, depending on how big the part is, the configuration of it. For instance, I've already plated the canister, the air cleaner canister for the YL1, which you'll see in an upcoming series of videos. And it took a little creativity to figure out how best to suspend a fairly large part like that and get even coverage of the plating. I could have threaded a bolt in here and looped the copper wire around that. I could have run something like this right through the holes here. Let me get this down where you can see it. Like this. There's all different ways you can do it, but this is nice and simple. And that'll just suspend the clamp in the solution, something like that. And what we would typically do is, or what I would typically do, is just take this wire and loop it around a couple times like that. And I think you can see how I've got that. Let me get this here at a different angle for you. You can see how I've got that suspended. But that's ready to go as far as the part itself goes. Now we have to position the sacrificial anode, and this is the zinc strips I talked about earlier. Again, you have to be a little creative. You have to think it through. What I'm going to do here for demonstration purposes, I'm going to use the new zinc. That's this side. And I'm going to just bend it a little bit so it lays across the bottom. Set this aside for a moment. Something like this. And I'm going to use 2 of them. You can use as many anodes as you wish. You can use 4, 5, 6. In some cases you might want to. For a part like this, I'm only going to use 2. And it's okay if the anodes touch. You can see there in the bottom. That's perfectly fine. What you can have happen is have the part touch the anode. You do not want that to happen. So there's the setup. I think you can see it right there. Real simple. And again, if I wanted to, I could have run 2 more. I could run anodes like this and this in addition. But what I do instead of that, I typically will rotate the part during the process, like you see me doing here, to offer up different sides of the part directly to the anode. That's fundamentally the setup. I think what I'm going to do is I'm going to bring this up a little bit. That is, bring it up in the bath. I felt it was sitting a little bit too low for my taste. There. And I leave this pigtail up on the stranded wire so that I can connect the cable from the cord from the power supply to the part. Now we're going to add the plating solution, and it has to be up above the part. The part has to be completely submerged. I think what I'll do is I'll just take this out for now. See if I can't give you a little bit better perspective. And I'm going to fill this clean container, and I did wipe the container out with clean acetone. So it's clean. I know it's clean. There's no oil or contamination in there. My wife saves these kitchen containers for me as she purges and changes and whatever she does from time to time. She just accumulates them, puts them in a plastic bag, leaves them in a garage, and I know that's my signal to that they're mine. So I have all kinds of these in different shapes and sizes. There you can see the setup, I think. Let me get the camera maybe a little bit closer for you. Here to look down. The two anodes on each side. The part is suspended. The solution is up over the top of the part, and if you're ever in doubt and you've got the room in the container, you can just add a little more. That's the inside lid of the cap. Fell out. Now we're ready to plate. Let me pull you back a little bit here so I got room to work. Now we have to hook up the power supply to the anodes and the part itself. Next thing I'm going to do is I'm going to use a jumper wire. That's what you see here. It's just a jumper wire to connect the anodes, one to the other. And the reason I'm going to do that is I want to supply power to both of the anodes at the same time. So I run a jumper wire from one to the other. Now if you have 4 of these anodes, you'd have another couple of jumper wires because you'd have to jump between each of them so they're all connected together, that is the anodes. Since I have 2, I can run the one jumper wire. If I had 4, I would have to connect them all. Now it's a matter of bringing the power supply into play. Now, as I had mentioned before, I had put that little cheat label on the top of my power supply. So the red cord goes to the anode, like that. And then the black goes to the part, and that's what I use this little tail for right here. I'm going directly from the wire to the part. Now I could clip here, I suppose. I have done that in the past, but what I'm trying to do is get as close to the part as possible. If I want to be even closer, I can do that. So black to the part to be plated, red to the anode, or anodes if you're using 2. I've connected the 2 anodes with this jumper wire so they're both getting current. Now we're going to go ahead and turn on the power supply. And let me get the light back out of the way here. And let's see what happens.